So let's look at another quadratic function real-world example called the Golden Gate Bridge. The Golden Gate Bridge, a suspension bridge, spans the entrance of San Francisco Bay. Its 746-foot tall towers are 4,200 feet apart. The bridge is suspended from two huge cables more than 3 feet in diameter, and a 90-foot wide roadway is 220 feet above the water. The cables are parabolic in shape and touch the road surface at the center of the bridge. Find the height of the cable above the road at a distance of 1,000 feet from the center. And this is the graph. Okay, so this is the actually the touch surface of the road, right? The roadway. And then you can see this is the cable, is the parabola shaped. Okay, so actually here is the vertex. Okay, so if we set up a rectangular coordinate system here with the coordinates 0, 0, and then it says the total span of this bridge 4,200 feet apart, right? And then we know the parabola have symmetrical property, so that means half of the parabola will be 2,100 feet apart. Okay, so that means this point's coordinates, x coordinates, will be 2,100. And then what is the y coordinates? So the total height is 746, and then the roadway is 220 foot above the water. Okay, so 746 minus 220, so give us 526 feet. Okay, so that's the length of this part, 526. So that's the reason why the y coordinates of this point is 526. All right. So based on the symmetrical property, and then this point coordinates will be negative 2,100, right? And then y coordinates is the same, 526. And then what we're looking for the height. Okay, this part. Okay, we're looking for this part. From here to here, what is the height? Okay, one is apart 1,000 feet from the center. Okay, so this point, x coordinates equals 1,000. Okay, we're looking for y coordinates actually. Okay, that's this problem. So how to solve this problem? We need to find a quadratic model, right? So if we write as a vertex form, is f of x equals a times x minus h squared, right? And then plus k, right? This is called a vertex form of quadratic function. And then we know the vertex, okay, h equals 0, k also equal to 0, right? The vertex is right at the origin 0, 0. So that's why we can simplify this function as a x squared, right? X minus h still x squared, ax squared. K is 0, so that's only ax squared. So quadratic function, the only thing we do not know is this coefficient, leading coefficient a, we do not know, right? So how to find the leading coefficient? We know one point, right? So all we need to do is plug in this point into the quadratic function. Okay, so I put it up, okay. We plug in, so a x squared, right? A x squared should equals y, right? F of x, which is y. So let's plug in this point. X equals 2,100, y equals 526, right? So we can solve for the a. A equals 526 divided by 2,100 squared. Okay, so we can keep this because this, if you really calculate it, is a very small number. Okay, so now we can update the quadratic function is f of x equals a, which is 526 divided by 2100 squared and x squared, right? So you may wonder why we don't find a value here. You can if you wanted to, okay? But since our goal is evaluate when x equals 1,000, right? What is the corresponding y? That's why this coefficient, equals specifically what number, we really don't care, okay? Our goal is trying to find the y coordinates of this point, right? When x equals to 1,000, what is the corresponding y? So now we replace x by 1,000, right? So now we want to evaluate, okay, let me write here, f of 1,000, okay, that equals 526 divided by 2100 squared, that's the a, right? And then replace x by 1,000 squared. So you put this whole expression into a calculator, and then we get the answer approximately equals 119.3 feet. Okay, it's like my calculator show it's like a 11927 something. Okay, so we can round it off, keep one decimal, that's 119.3. So now we can answer the question. The height of the cable above the road at a distance of 1,000 feet from the center is 119.3 feet. Okay, and then the detailed solution, you can see the next page. Okay, and pretty much the same process.